Right. As mentioned about the types, it is classified into two categories. One is the intermediate system, another one is continuous system. The intermediate system includes job production and batch production. The continuous system includes mass production and process production. Okay. So here, with variety versus volume, with that graph, we could be able to understand that if volume is very less, comparing, it's always comparing with somebody or someone or something, right? So here, jobs of production comparatively with the other types of production, volume is very less, but comparing to other production methods, variety wise many, huge, comparatively higher. Okay. For example, machine tools and prototypes. That is what I said. Okay. And batch production, if you go, which is less in variety comparing to the job shop production, but higher in variety comparing to mass production. Volume wise, little higher comparing to job shop production, lower than mass production. Similarly, each and everything will be related. For example, continuous flow process, variety wise very low compared to all other three production methods, but quantity wise it is huge number of quantity is there in continuous flow process. Examples like oil refineries, iron and steel or chemical industries, and appliances industry will be coming under the mass production, and batch production is foundry or food processing industry. Then jobs of production is all about machine tools and prototype. So we'll discuss about each and every production methods or system, and what are the characteristics of that particular system, and what is the pros and cons of each and system in this particular video. Okay. Okay. So what is meant with continuous or mass production? Okay. To produce standardized products with a standard set of process and operation sequences in anticipation of demand, this ensures continuous production output. So the wording what I have highlighted is very important here. To produce products, no. To produce standardized products with the process, no. With the standard set of process. Products are different, standardized products are different. Process are different, standardized set of process are different. Okay. And standardized operation sequence is different. Randomly we are doing some preparing some product with different features, that is different, and that is like job shop production. There is no standard maintained there. They prepare some quality according to the need, but standard maintaining standard is not available. Okay, but in terms of continuous and mass production, we have to maintain product with the good standard. Okay, then if we go for mass production or continuous production, if we are maintaining standard set of procedure to machining it or manufacturing it or fabricating it, we won't be able to get desired quality in all the components what we are producing through this mass production process. So what is the example we saw in terms of mass production in our previous slide? See, mass production is all about appliances and bicycles. Example, appliances, if you take grinder, mixie, cookers, bicycles and another thing they mentioned, right? If we don't maintain standard set of procedure to make that component or product, what will happen? We won't be getting quality products, right? If everybody maintaining different manufacturing process for making individual cooker, like a 5 liter cooker if you take, or bicycle if you take, anyone, if we are maintaining the standard set of procedure to produce that particular bicycle or pressure cooker or mixing, then what will happen? Each and every component will be having different means. It won't be giving the desired functionality of the particular product, right? It definitely create a huge error or failure for the particular component or product, right? So we have to maintain standard set of process to the operation according to the demand what we have, and also we have to do the standardization of the product. In the sense, every bicycle we can't able to produce in different uh, dimensions. We have to set, because if we have a equipments, machineries, production line defined properly, we can't simply change for every component. For example, in again I am telling like a bicycle, every bicycle we can change dimension. Custom made is different, but mass production, when we go for mass production, we have to first fix what kind of product we are going to make, like a dimension wise. Okay, with the example I will give what is that standardized product. Okay, and also it is also referred as a mass flow production or assembly line production. That's what I mentioned. It is mass production in the sense, usage of assembly line is very vital in this kind of production system. Okay, and this system results in less work in process inventory. Okay, WIP generally they used to say is a work in process, which this system results in less work in process inventory, but involves high capital investment in machineries and equipment, because it's all about assembly line production or mass flow production. So what we have to do is we'll be investing lots of money for the on the machineries, on the equipments. If we construct assembly line, it is not like removing day by day. It will be fixed for prolonged time, like 2 years or 3 years or 4 years. But little changes needed means we can able to do that. Flexibility also should have in that layout what we are designing, right? For that we'll be investing lots of money. That is what the capital investment is there in the on the machineries and the equipment. Okay, so this will give less work in process, but a huge investment. But we can able to achieve standardized products, and also if we invest high and proper planning we do, we can standardize the set of process and operation sequence to make that particular component. Okay, and this is comes under large volume, small variety of output. Example: oil refineries, cement manufacturing industry, or sugar factory. Okay, so here, because it's a continuous and mass production, in the sense it's oil refineries and cement manufacturing and sugar factory. If you can understand that oil refineries, they will be taking some from the ground like crude oil and all, they segregate, do the lots of process and lots of sub components from that particular raw material they will be. Similarly, cement manufacturing industry also, sugar factory also take from the sugar cane, and they will do lots of process, and sub products will be many. Okay, sub-product in many, in the sense you can't go for a 10 to sorry 1,000 sub variety. Like from sugar cane we can able to get like sugar or some other chemicals. By adding that they will, so variety will be less, but volume wise they can able to make. Okay, similarly cement factory also, cement factory from that they can able to make small variety of output only, but they can't able to make n number of variety from the cement manufacturing industry. Okay, so this is the basic introduction about what is the continuous or mass production. Then what are the characteristics about this continuous or mass production? So you could refer from these slides. Like this is again I am mentioning that the source is from the MP Gruber book. Okay, so characteristics. What are the things? Most of the machines are semi-automatic or automatic. What is semi-automatic? What is automatic? What is manual? So here manual is the sense like a conventional machines like a drilling machine or grinding machine or lathe machine and that. So machine spindle speed or feed is there, but operator needs to operate it, and he needs to give the depth of bed, he needs to do the feed and that. Okay, So that is mainly manual. So machine also there, but the manual work will be more, like a significant amount of work by the man or worker. But in terms of in this continuous as mass production, semi-automatic, that more than significant amount of work done by the machineries, okay, are fully automatic in the sense very very less significant. There is no significant involvement by the operators or workers. They will be part of that, but like just they will monitor that and switch on, switch off that one. Okay, they will control the process, but not significantly. If we take not much input from them in terms of this particular production system. So most of the machines are semi-automatic or automatic. Then semi-skilled workers are normally employed because it's a machines running everything. Machine is doing all the operation. In the sense, we no need any skilled operators for doing something. But before, when we do that investment, when we design a system like a layout and all, we need people to develop the system. However, when we go for operation or production, that time we doesn't need much skilled laborers for that. Okay, and cost of production per unit is very low owing to the high production rate. Right, once we increase volume of product more, then obviously production cost will go down. Hope everybody agrees that, right? So this is what it is mentioned, like cost of production per unit. It is very very important. Per unit is very low owing to the high production rate. So if production rate is less, what will be there? Cost of the per unit will be high, right? Like vice versa. So in this case, production is very high, so that production cost per unit will be lower. And inventory of workers, work in process is small because work in process will be less in this particular production, so it will be continuously moving. So inventory and work in process is small. Material handling also automatic. If you consider like a cement factory, it is continuous production using conveyor belts, right? It will be traveling from one place to another place, continuous trains. Most of you guys might have seen some of the cement factories and all. So in that, mostly they use conveyor belt. Continuous it will be running automatically without any break. It will go on. Okay. Then small variety and large production volume, as we discussed in the last slide, and predefined line for production flow used. We should be very clear that what we are going to do. So accordingly, we have to design our production line. So that's what it is mentioned, like a predefined line. So we can't simply change it in between the production process, like instead of going from route A from A to B in this way directly. If we are suddenly want to today, it should go to A to D, E, F, G. No, it's very difficult in terms of this one because it's almost like a fixed lines we have to do. That's why it is mentioned like a predefined line for product flow used. Okay, planning and control of this system is easy. So once the initial planning is very very important. Once we do the planning, after that controlling is easy because we are very clear about how we are going to do that and what way it is running. Okay, so no need to worry about too much thing on controlling this particular kind of system. Okay, this is what all about continuous or mass production system. So next topic is about job production or unit production. It involves production as per customer specification according to the individual need or individual in the sense maybe we can call it as a small group of customers. Okay, comparing to mass production customer. Okay, so that's why I always used to say it's a comparison is very very important. Comparing to the mass production, we have to consider that the customer will be very very focused group or limited group. So this production method or like a job production method or otherwise we can call it as a unit production method, which is production method for customer specification. Okay, so what are the characteristics available for this? Most suitable for heterogeneous products. Okay, so mainly for one particular type of customer, and manpower should be skilled enough to deal with the changing over condition because customer specification changes by one to another. Like a small group of people to another group of people, they will expect something different. Okay, in that case, the power resource persons like manpower, who are all workers, they have little over skill to do this kind of activity. Okay, some design they are requesting in the sense like particular customer need a specific design, other customer need different in material conditions, right? In that case, that manpower who is having doing the R&D work or designing that or fabricating that, he should have little skill to handle the particular situation, because then only they could be able to achieve that. And production cost is normally high. Since it's a job production, everything we have to plan according to the individual customer need or small group of people need. So production cost is normally high because high material and labor cost. Labor cost is how it is high because skilled laborers or skilled manpower will be utilized. So cost for them will be high. Okay. Comparatively, smaller investment in machines and equipment is available. First of all, in this kind of thing, they will be understanding that whether I can able to do in this particular component in my industry, knowing that what are all the equipments available. Definitely, they don't have for this kind of production system. Don't have like a huge CNC machines, n number of CNC machines, n number of conveyors, material handling devices, and all. Okay, they will be having specialized instruments or machineries in few number. With that, they will be able to do that. Okay, so that one is in the sense investment will be low. In the same wise, limitation of creating volume wise component will be low here. Okay, so that's what where it can be done more, but volume wise they can't able to do that. Flexible nature, and it can be adapted to change in product design and order size. Yes, of course, like as I said, like this is like a individual need, like a specialization for the customer need is in the sense there is a possibilities for changing the flexible thing. Okay, so simply they add on something in their particular machine, means it's not completely they will be changing the machine, they will add some like a collet or they will add some fixtures. With that they can able to change them, or they can able to produce the particular need of the customer. Okay, so according to the design they can change. And also order size. Order size again, don't think order size in terms of like a huge numbers like a 20,000, 30,000 or 1 lakh or something like that. Here order size may be 10 or 50 or something like that, very limited. Again, it should be comparable with the other production type. Okay, grouping of machines is done on functional basis. If for example that particular small production industry they have like 10 machines, according to the particular nature of the product, they may group the 10 machine into 4 machines. Like they need a milling machine and a shaping machine and grinding machine. That's it. Then cylindrical object in the sense they'll be using like what to say, grinding machine and like a turning machine for that. Okay, then assembly location also, but it is very limited number of machines only. So grouping of machine also very easy according to the functional need of that things. Okay, this is what all about job of production. So next one is intermediate production, or otherwise we can call it as a batch production. So production of different types of product in small quantities. Here, variety will be comparatively higher than jobs of production, and volume also little bit higher than the jobs of production. But comparing to the continuous or mass production, volume is very low. Okay, so here production of different types of products in small quantities like batches is possible. Goods may be produced partly for inventory and partly for customer orders. Means they will be continuously do some manufacturing and keep something as inventory for them, and something they will be making and giving to the customer. So, how to understand this? What is the example? Components are made for inventory, but they are combined differently for different customers. Example: automobile plants, printing presses, electrical goods plants. Okay, for example, automobile plants, they make it and they keep it as an inventory also. Suddenly, the some particular main so client is asking some component, they will be selling that, and they will keep something for their inventory. Other customer will ask again, they will sell it. Okay, for automobile, you will be understanding that like for example, some crankshaft or piston or connecting rod if you go for engine itself. So the size will be, if for example 4-stroke engine or 2-stroke engine, whatever it may be, the dimension may be fixed in the sense they make like that in huge number. But according to the individual customer, because lots of automobile providers are there, A, B, C, D, so many things are there. I don't want to name. individual company name here. So they have lots of things. They will be asking like the piston manufacturer. Then maybe he is sold for making piston with designed quality and the sizes. Okay, so he will be producing continuously and keeping it with them. And whenever that company A, B, C is asking that particular piston or connector, they will be giving that. Similar for the printing presses also, or electrical goods and plants. Then, in the sense, they'll be using the piston for their own engine design, and also they'll be giving their piston for the other company who is making a different type of engines. Okay, this is the example for how we can do the goods may be produced partly for inventory and partly for customer orders. Okay, so what are all the characteristics of this? Grouping of machine is done on functional basis, similar like that one, but the machinery is available here a little bit higher than the job shop production. Semi-automatic and special purpose machines are very much used here. Special purpose machines are very needed in this thing like a wire EDM process or ECM, ECM methods and all. Okay, labor should be skilled enough to work upon different product batches because so many batches will be there. Because simple example is in the piston itself, I am telling the dimension wise little variant will be there. Okay, so different and tolerance requirement or material requirement will be different from one piston to another piston. In the sense some skilled labors are needed for that, and process inventory usually high. So you have to store, since it is stored in something in the industry and something will be sold out. In the sense storing is needed. It's a kind of investment only, because simply you can put it somewhere. It should be properly kept stored there in order to use that properly, or functionality of the component won't be destroyed. If we are not storing properly, it is merely waste. So inventory usage of the inventory usage will be high in terms of intermediate production system. Okay, so with that, I'm moving to all together. Like generally, we say five types, continuous production or job shop production, like a discrete or intermediate production and all. We saw that, but here it is again it is mentioned in terms of repetitive, repetitive in the sense doing the same thing. Like if we make one particular grinder, or if we make particular piston, continuously make the same piston. And discrete in the sense A, B, are like variations, like with different in sizes, okay, different in dimensions. So if we make that, that is fine. But in terms of job shop, one particular one particular work will be done. Then again, if we consider a different variety and different volume, okay, but volume is low, but variety will be high. So variety will be high in terms of like a job shop. Here, each job will be having different in nature comparing to the previous one. Okay, so that is what it is mentioned like E, F, G, H, E, I, F, J. Okay, in that case, each job what they make is different from the what they already done. Okay, at least little different will be there. Volume wise, like a very small number only. Process or batch wise, if you consider, like they make like a batch wise, like a small group of batches, but multiple variety will be there here. Okay, C, C, D, R, E to J, they combine together in batch, one batch and two like that. Okay, the process continuous. It's a similar like a cement factory or oil refinery industries or sugarcane industry. If we say they make a continuous production, separate line. Okay, individual line they will make. But all these five methods is the commonly mentioned as types of manufacturing system. But now the era is came to is additive manufacturing. So what is additive manufacturing? As explained during in the introduction also, or during that industry 4.0 components or technologies which is embedded with industry 4.0 also, I named about additive manufacturing. Additive manufacturing is adding something instead of removing something. Okay, it's not destructive, this is constructive manufacturing process. Constructive means making something out, making something new. That is what additive manufacturing also. Okay, so it's not we are not going to discuss much or more detailed about additive manufacturing. We'll give little introduction for you guys to create some awareness on that. Okay, because there is another subject like rapid prototyping or additive manufacturing in your curriculum, so you could be able to learn too much detail in that. So I will give a brief about what is meant by additive manufacturing. So additive manufacturing, simply they call it as AM, is an appropriate name to describe the technology that is built 3D objects by adding layer upon layer, in the sense layer by layer on particular time. For example, one time they add one layer, after completing the process, next time they add another layer. So layer upon layer of material, they will be adding the layer upon layer of material. Okay, this is what additive manufacturing. That is what I said, adding. Okay, whether the material in any form. For example, they mentioned like here is plastic, metal, concrete, or one day, why not? Human tissue also can be made using the additive manufacturing. Means they make layer by layer, and at a particular time they add one layer. After that, another layer they will be adding the material in the form of plastic or metal, concrete, or one day we know that human tissue additive manufacturing also possible. So commonly how they do? Commonly the additive manufacturing technology will use us like a computer for making three-dimensional modeling. For three-dimensional modeling, you guys know about CAD softwares are there, computer-aided design softwares are there. Using that design software, you could able to model what is the component you want or what is the design you want. Because drawing is different and modeling is complicated nature of feature within complicated features. If you want to make designing is very easy tool, so you can able to design that. Okay, but if you design that complicated nature component, how you are going to make it in real world machineries, it is little difficult, because traditional manufacturing process is what it is doing, it is removing the material from the bulk raw material. Okay, okay, so in that case, if the component having interior profiles and grooves with the different curvatures, and how we can be able to machine that one. It is possible, but lots of thinking we have to do, lots of development we have to do, and lots of process we have to do. Tooling design or fixed design is huge investment and time needed for that. So to avoid that, the additive manufacturing will easily providing the solution that layer by layer, if we add the material according to the need of the or feature or design of the component, it is easy to fabricate. So what we have to do, we have to do the 3D modeling of the particular component using some CAD software. The CAD software files will be transferred to additive manufacturing machineries, either in the STL file format, stereolithography file format, .stl file format. Then that particular machine will do the 3D printing. Okay, so under this additive manufacturing, what are the subsets or classification? Simply we can call it as a it's a 3D printing, and we can call it as a rapid prototyping, and direct digital manufacturing, or layered manufacturing, and additive fabrication. So these are all the subset available under the additive manufacturing. Okay, what are the things? 3D printing, rapid prototyping, direct digital manufacturing, and layered manufacturing, along with additive fabrication. So this is what basically additive manufacturing is. So understand that it's adding material, it's a constructive manufacturing method. Okay. Just I want to show you a video which is provided by General Electricals about what is additive manufacturing, because they are going with they are planning and they are adapting additive manufacturing technique. So let just go through this video.
What is additive manufacturing? Additive manufacturing, also known as 3D printing, is a process that creates a physical object from a digital design. An engineer designs the object using computer-aided design, or CAD software. The 3D design file is then sliced into thin layers and uploaded to an additive manufacturing machine. The manufacturing process begins once an extremely thin layer of metal powder is spread across the platform. A heat source, such as laser or electron beam, then melts the first layer of the 3D design. The platform is lowered, and another layer of metal powder is spread across the platform. The layering and melting process is then repeated until the part is complete. The metallic powder is removed, and a physical object is revealed. Additive manufacturing allows you to produce parts that are lighter, stronger, and more durable than traditionally made parts. Build times are faster. Engineers can add precise features and complex geometries without increasing cost. In fact, additive manufacturing is revolutionizing the way we work.
So, it's interesting video, right? General Electric, electrical, so GE's additive manufacturing concepts. So, as they have mentioned, complex geometry, we could able to make it very easily and cost-effective manner with good quality, like accuracy wise, and it should the output will be more stronger or durable than the what we make in real manufacturing, like traditional manufacturing. But lots of research needs to be there, needs to be done on additive manufacturing because simply we are adding like layer by layer. You have to test because we are claiming that in additive manufacturing, it produces strong and durable kind of thing or lighter thing, lighter material can be used in the sense. Simply, we can't add some material. We have to do material study because adding a lighter material in the sense where how it is going to be durable, how it is going to withstand the stresses, going to thermal stresses or mechanical stresses applied on that. Okay, we have to do a clear study before we are going for additive manufacturing. But it's additive manufacturing is a technology. It uses the CAD design and it will be printed layer by layer, and we can able to get the desired component for the complex geometry. Okay, time consuming also. The time consuming will be eliminated in this one. It's very easy process. The complex geometry, as you saw in this particular video, if they that particular component needs to be manufactured in real or traditional method of manufacturing, it takes lots of time. But in 3D printing or an additive manufacturing method, it is a simple quick process. Just to give the file, then it will layer by layer, maybe 3 4 hours or 5 hours according to the uh, capability of the particular additive manufacturing machine will be done. Okay, then these are all the types available. So I took this from source just to show whether all the additive manufacturing types are mentioned in this slide. I will be telling no, just to give some idea like what are the way they are classifying. That's why I'm added this slide. So in additive manufacturing, based on physical state of the particular raw material. So based on raw material, they are classifying the additive manufacturing as solid, means raw material state is how it is, solid, powder based or liquid based. In terms of solid, they have lots of method to make that process, like a manufacturing process in additive. Like in solid, they'll be using fused deposition modeling and wire plus arc additive manufacturing, then electron beam uh, free form fabrication. These three methods are comes under like a solid based system. In solid based system, either extrusion process or wire process is there. Okay. Then in terms of powder based system under the additive manufacturing, they have lots of methods available here. Selective laser sintering (SLS) and digital metal laser sintering process. Sintering process mainly SLS and DMLS. One method. Another one is electron beam melting. Here also electron beam free form fabrication is there under the solid. But in terms of powder based system, electron beam melting process is there, and selective laser melting also there. Okay, selective laser sintering one method, selective laser melting is another method, and fused metal deposition LMD method also there. Okay, so here fused deposition modeling, but here fused metal deposition. This is another method under the powder based system. And in terms of liquid based system, SLA method, stereolithography method, and direct light processing method, DLP method. So this is the simple classification I am telling. Whether all additive manufacturing classification came in here, no. and how it is how it is made. The process method is maybe lots of classification also there, but I don't want to discuss much about that. Just to aware what are the methods available, what is additive manufacturing. That's why I added these slides in this presentation file. Okay, let's move on to the next concept under the manufacturing. So this is 3S concept. What is 3S? Yes, represent 3S represent. First one is simplification, standardization, and specialization. These are all the very, very important three S's in terms of manufacturing system. Because in some places we used where to say, yes, yeah, in continuous or mass production, I said like a standardized products, right? So standardized product or standard setup process and operation sequence we mentioned, right? So we'll discuss about what is about each and everything. Like a simplification is what, standardization is what, specialization is what. Okay, we'll see. What is meant by simplification? It is a process of product analysis through which unnecessary varieties and designs are eliminated. Simplification, the word itself, we know that we have to make it simple. Make it simple, right? What is that? It is a process of product analysis through which unnecessary varieties and design are eliminated. Simply, you can't keep everything in your company for making. If you have n number of varieties, because customer will ask so many things. If we keep all the input from the customers, means input in the sense in terms of design, we can't able to make anything in our industry because it is so difficult to satisfy each and every customer. In the sense, we have to prepare very big in our industry, like equipment wise, manpower wise, tooling wise, resources. What are the resources wise? We have to provide. Investment will be huge, time taking. But if we could able to eliminate unnecessary varieties and unnecessary design, then we can able to satisfy the customer also. But 100% is not possible, but we can take almost like 99 percentage of people our customer to satisfy. So the process of making that, the how we are going to make, how we are going to eliminate the varieties, how we are going to eliminate the unnecessary design is called simplification. So how it is there inside the industry? Simplification is a point of disagreement between production and the marketing department. Why it is told like that? As I mentioned, the marketing team, sales and marketing team is voice of customer for our industry. So they represent customer voice to us. They are like a representation of the customer. They observe what are all the things customer are expecting and will be delivering to the main our research and development team. Okay, so here there will be a disagreement between the production team and the marketing department. Okay, why? Production department favors what they think. They will be thinking like minimize the variety. Why they want? They are thinking like minimizing the variety, so that it reduces the number of setups needed for making that making the particular component or product, and also utilizing effectively the production facilities which is available in the particular industry, and also reduce the cost to make that particular component. Okay, this is what they think. They want to think minimizing the variety so that they can effectively utilize the production facilities which is available in their industry to minimize the cost. Because simply they have you not using properly and increasing the cost of the company, nobody going to buy, right? So that's what they mentioned. To minimize the variety, they will be thinking the production department people, so that they will be minimizing the number of steps going to be manufactured, and effectively they will be utilizing the facilities which is available in the industry to produce the component and also to reduce the cost of the thing. That is what they think. But marketing people will be thinking like what? They favors like a high variety, because customer be expecting that they want this kind of style, this kind of property, this kind of color. So many variety they will be expecting. So everything will be communicated by the marketing to the production team or to the industry. Like the marketing team will be expecting like I need a huge number of variety so that I can able to sell our product in the real world easily. And also I can able to meet large number of customers. So you have to make like lots of variety of component like that they will be claiming. So what we have to do, production team is expecting something, marketing team expecting something. So we have to sit together, we have to analyze each and everything and make optimal way so that we can utilize what are all the facilities available in our industry effectively, and we can deliver the product on time and reduce the cost of each product. Okay, that is the way, that is the process is called simplification. So, what are all the advantages of doing simplification? It's a simple, direct answers you can get. It could reduce the inventories of materials and components. Until otherwise, we decide and limit our varieties, uh, inventory will be huge. So, if we discuss together with both marketing team and production team and minimize the varieties we want, we could able to reduce the inventories of the material components we want. Okay. Another one is reduce the investment in plant and machinery, of course, and space required for storage of material. If variety is less, we can utilize, we have clear planning for that and keep. Ease of planning and control, because we decided. So planning will be easy for us because random design, random variety, we are planning only, it is a cumbersome process for us. But here, after clear discussion, it is easy for us to plan. Okay. And reduction in selling price. Cost wise, the product cost wise will be lower. That is the main objective for simplification, right? Cost should be minimized because effective usage of component or facility which is available in industry is happening here, so that cost per unit will be reduced, and inspection methods also very easy. But what is the disadvantage? We can't able to meet out a wide variety of customer requirement. Okay, because marketing team asked for feedback from the customer, and again we discuss among the industry people ourselves, we discuss and make something and give. But the customer who specified a particular requirement, if he is not getting that, he will be upset, right? He won't be satisfied. So that is, in that case, we may lose that particular customer. For example, that same requirement by the customer is fulfilled by other company, then they will move on to the particular company. So here we will be losing that particular kind of group of people, group of customer. Okay, so this creates always constant source of conflict between both the team, like marketing team and production. Because one customer is out from their list, then marketing team or sales team will feel like their selling person will be reduced. Then pressure will be added to on them. Right? So it creates some overload, the stress on them. Then there will be conflict between the production team and the particular marketing team. So we, but cannot be avoided. This cannot be avoided. So simplification is the process. We have to sit together and make less varieties, minimize the varieties, and minimize the number of designs. Effectively utilize the facilities which is available, and meanwhile we have to reduce the cost per unit. Okay. Next one is the standardization. Mostly we discussed about standardization in our production method. It is the second step of the simplification. Once we decided this is what we are going to do, removing all the varieties, many varieties, and finalizing this is the variety we are going to do, and the design this is the design we are going to do. So after this simplification process, we have to do this standardization process towards interchangeable manufacturing. What is interchangeable manufacturing? We'll discuss in the coming slide. Okay. Having selected the varieties and the grades of products to be retained as much of its manufacturing details are standardized as possible. Once we decided the varieties, what we are going to do, we have to standardize manufacturing process for making or manufacturing the product, standardize the product what we are going to do. We have to standardize that. After that, we should not change. Until otherwise, it's pretty needed. We should not change the set of procedure what and how we are going to do that particular company. Okay, since Manufacturing involves large number of decisions from the selection of raw material to the process used for finishing. Standardization of some of these items reduce unnecessary repetition of work. Okay, because manufacturing is a large process from raw material to final. It may travel like a simple components is fine. No? It may go to few machines, but lots of big assembly. If you take like a car has a huge number of component assemblies, sub assemblies, individual parts. Okay, where we have to standardize that. Simply we can't change here and there, right? We have to first standardize what are the raw material we are going to do, how we are going to process that one, and how we are going to assemble, how we are going to inspect, and how we are going to dispatch it. From the A to Z of the industry, we have to standardize before we are going for the real. Then only we can able to make it like efficient way. Okay. So use of standardized component reduces the inventory cost, ensures interchangeability and make future maintenance easier. Okay. So here also I mentioned interchangeability. We'll discuss about interchangeability as I said in the coming slide. But so what is interchangeability? The various components are manufactured in one or more batches by different person on different machines at different location and are then assembled at one place. So how many independent are here, independent variables are here. So one component if we take like one piston we are thinking, okay, you take the piston, okay, the piston manufacturers are there, okay, it is manufactured in terms of one batch or n number of batches, okay, this is one part and will be manufactured by different person because workers are there, worker different batch wise like a shift wise many workers will be doing. If you name like a three shift that particular manufacturing industry is working, like you can assume like a huge number of workers will be involved in making that particular piston. Okay, so different person involved on different machines because piston or connecting rod not done by one machine. It will go through multiple machines on different locations also. For example, heat treatment process or making process or hole making process or assembling process will be done in different location. And finally, it will be assembled inside the engine at one place. Okay, so various components are manufactured here, like in terms of batches and by the different people, different methods, different machineries, and different location. So, what is that? It is essential that the parts are manufactured in bulk to the desired accuracy and at the same time adhere to the limits and accuracy of the specification. For example, by making batches in n numbers in different places by many people or many machines or in many locations, but quality or accuracy, what we need should not be compromised. It should be what we needed accuracy. For example, zero point zero 0.05 accuracy we need means we should attain zero point zero 0.05 accuracy in all wherever we make and who are making in what machine we make. It doesn't matter. We should need zero point zero 0.05 in the sense we should need that. Okay, that's it. That is what interchangeability. That is what very important for standardization principle. If we are not doing that, we can't do standardized products. Like standardized product in the sense, product should be standard in everywhere if we make. For example, industry having multiple plants, like maybe in one city, another manufacturing plant in another city, or in another country maybe. All the things going to be assembled at one place in different country possible. But each one, like a male, like one shaft and one what you say, one hole going to be assembled together means the whole should have the particular tolerance or limits and fits. The shaft should have that limits and fits. Then only it could be able to assemble it together. Otherwise, you can't able to assemble together. So standardizing that very important. Do you think it is easy to do interchangeability? For example, assembly a lot, as I said, like a hole and a hole is here, shaft is here. There are multiple people who are making these holes. Okay, using multiple machine, different machines, and different workers who have made this. And similarly, the shaft also made by different machines and different employers and different places. If we want to assemble, take any one from here and put it here, it should be assembled properly. Similarly, take anything from here and make it assemble here, it should be assembled. So interchangeability in the sense from any one slot You are taking another from the another slide. If you're taking and making assemble together, it should assemble with the desired quality, with the desired accuracy. Then only it is called as a standardization process, or it is considered the interchangeability. If we are not attaining that, we are not satisfying the required product. Okay. Example they mention like here is 1,000 component, here is 1,000 component. If we take any one from this 1,000 lot and another 1,000 lot from here, any one from here, and make it assembled, it should be assembled. Okay. That desired fit, we should get it. That is what called as the interchangeability. Do you think it is easy process? It is not easy process because challenges will be there, lots of challenges because you have to invest lots of money for making that product as per the required dimension. So challenges will be huge. Okay. What are the objective of standardization here? Interchangeability of parts, keeping the variety minimum, helps to achieve the better control due to the reduced variety. Okay, advantages will be reduction will be low, inventory will be low, and we can able to maintain the accounting properly, and ease of procurement because of availability, reduction maintenance and repair cost. Okay, because if we make it properly, we make the standard component, then error limitation will be minimal, so we can save some money. And what are the classification where we can able to do the standardization? Basic standardization means we can do scales and weight, like length of the component we can scale, or weight of the component. For example, if we want to make the component with some grams, like 200 grams, in the sense everywhere we have to maintain 200 grams. Our size wise, if we want to make like a 10 centimeter, it should be 10 centimeter with some limitation. If we say like limits instance 0.05 or something like that, and what kind of texture we want to achieve. So basic standardization we can able to do, and dimensional standardization. For example, nut, bolt, and screws, gears, and because it's mostly the nuts, bolts, and screws will be used in many places in many industries. So each and everybody is making different sizes of bolts and different sizes of nuts, and they are using in different sizes. It is difficult to fabricate. So mostly they have to standardize that. Okay, like M10 bolt or M15 bolt or M12 bolt. Accordingly, for M12 bolt, there will be nuts also will be related, right? This kind of standardization they have to do in terms of dimensions. Then material standardization. What kind of material they are going to use, what kind of coolant they are going to use, okay, what kind of lubricant they are going to use, what kind of tool they are going to use, and equipment wise, what specification and what kind of layout they can design that. This kind of standardization and process, whether they will be using turning operation, grinding operation, or welding operation. They have to standardize before they are going for their real making. And what kind of quantity standardization? First of all, they have to understand that economic order quantity. Simply, they should not do. They have to get the investment back. Okay, return of investments should be there in minimal time. So that means we have to identify economic order quantity. What way we can get the return of investment, whether it's economical for us, we have to know. And safety measure standardization, we have to make rules and regulation for that. Okay, and final one is personal standardization and administrative standardization. Okay, so with this, I will continue this in upcoming slides. So we discussed about the standardization, like lots of classification for standardization is available, from the basic standardization, dimensional, material standardization, equipment standardization, process standardization, safety measure standardization, personal standardization means that we have to select particular worker with a particular desired knowledge, and administrative standardization in how we are going to manage that office worker works. That also we need the standardization. Okay, these are all the methods of standardization. Next topic is specialization. We'll discuss about the specialization in upcoming videos. Okay, thank you very much.